Hi, this is Mr. Campagna. Today we're going to be taking a look at Snell's law, specifically how to identify the refractive index of a mystery material. Now before we get started, please make sure that you have a copy of Snell's law grapher. It's an Excel file. You can get that from your teacher before we begin. This simulation will conclude the work that we started in the previous two lessons. We're going to be using the same simulation, PhET's bending light. Let's start by clicking through on the link. And the simulation will load up. You're going to click through on Intro. And same familiar setup as we had before. You got your laser here, you have your tools, and you have your materials settings. So let's head back to the procedure to figure out how to set this up. You'll notice here it says change the material of the first incident medium to mystery A and the second medium to glass. So let's go back to the simulation. We're going to change this to mystery A. We're going to change the bottom material to glass. All right, let's head back to the procedure and see what's next. So you'll notice here it says change the incident angle of the laser theta 1 and record 6 sets of results for theta 2 in the Snell's law grapher. This is on the Excel sheet. So let's take a look at that Excel sheet. Now, if your teacher shared it with you, but it's view only, you're going to need to make a copy. So that'll be my first step. I'm just going to leave it as copy of Snell's law. All right, so you'll notice here you have two columns that you can edit. One is called angle 1 and one is called angle 2. Angle 1 will be theta 1 and angle 2 will be theta 2. So let's go back to our simulation. So the procedure asks for us now to get 6 sets of data. How do we do that? Well, you'd start off by putting your protractor on the normal. Try to get it as accurate as possible because this will affect your measurements if you don't have it lined up properly. Next, we have our laser. And really the angles that we care about are the first angle, the angle of incidence, and then the second angle, the angle of refraction. Now, you can use any points, any angle that you want to collect as a data point. The only issue is if you get something that's a little too oblique like this, you'll notice we don't have an angle of refraction, so that wouldn't be a valid data point. Now, I'd like to model the simulation for you a little bit more, but without giving you the answers. So what I'm going to do is I'm going to change from mystery sample A to mystery sample B. You will not do this. You will leave it as mystery sample A because that's what the procedure calls for. So remember, we're looking for 6 different points. And we start off with 0 and we go all the way out to 90. In this case, I'll probably just go starting with 10, 20, 30, and just measure off from there. So 10-degree angle of incidence, and that gives me a little bit less than that, maybe a 9-degree angle of refraction. So I'm going to go to the Snell's law grapher. And if angle 1 is 10 degrees, and angle 2 is about 9 degrees, you can see it gives me the sine angle 1, sine angle 2, and it gives me the index of refraction for that material. But considering that we're on the lower end of the scale here, and our measurements may not be that accurate in the beginning, this is why we want to get 6 different data points to refine that number. So let's head back and collect 5 more sets of data. Here's 20-degree incidence, and it looks to be, let's say, 18 degrees angle of refraction. Let's head back again. 30 degrees, and that appears to be about 27. $40, that appears to be 36. 50 degrees, and that appears to be 45. And 60 degrees, that appears to be 30, 40, 50, 54. So this appears to have given us an index of refraction of 1.41 for our mystery sample B. Again, this is not the correct answer. We're doing B here in the model. You'll be doing mystery sample A to complete your assignment. All right, now that we have a possible answer for our index of refraction for our mystery substance, in this case, I'm doing it on mystery sample B. You will be doing this on mystery sample A. We're going to head back to the procedure now, and you'll notice that they give you a list of absolute indices of refraction for several relatively common substances. Where does the number that you pulled out of Snell's law grapher, where does that number compare to the rest of these? Can you make an inference as to which one matches? So if you were able to find one that matched relatively close, you'll notice that you probably weren't exact with your measurements. So let's try to figure out our percent deviation or our percent error. So you'll be using the formula that you have at the bottom, calculate it in the space provided. And that's really all there is to it. So I hope modeling this was beneficial and gave you some ideas on how to proceed. Remember, your data will look a little different than what I did for you here today, but all the same, now you know how to complete the assignment. All right, thanks for watching.